What is the integral of sine raised to the fourth power of x? Go ahead and try this problem. Now for this problem, you need to be familiar with the power reducing formulas for sine. Sine squared is 1/2 1 minus cosine 2x. So notice that the angle, it doubled from x to 2x. Now sine to the fourth power, what do you think we could do with this? How can we convert sine to the fourth into sine squared? Sine to the fourth is basically sine squared of x raised to the second power, because when you raise one exponent to another, you need to multiply the two exponents, and 2 times 2 is 4. Now our next step is to replace sine squared with this expression. So we have the integral of 1/2 1 minus cosine 2x, and this entire thing is squared. So the first thing we're going to do is square the fraction, 1/2 squared, and I'm going to move that result to the front of the integral sign. 1 squared is 1, and 2 squared is 4. And so we have the integral of 1 minus cosine 2x squared times 1/4. Now we need to expand this expression before we can integrate it. So I'm going to FOIL 1 minus cosine 2x with another 1 minus cosine 2x. Now let's FOIL. So first we have 1 times 1, which is 1. And then it's 1 times negative cosine, so that's going to be negative cosine 2x, and then negative cosine times 1, that's going to be the same thing. And then the last part, negative cosine 2x times negative cosine 2x, that's going to be positive cosine squared 2x dx. So let's combine these two like terms. And so this is going to be 1/4 times the integral of 1, and then negative 1 minus 1 is negative 2. So this is negative 2 cosine 2x, and then plus cosine squared 2x. Now we need to use the power reducing formula one more time. We mentioned it for sine squared, but now let's focus on cosine squared. Cosine squared of x is 1/2 times 1 plus cosine 2x. For sine squared, it's going to be 1 minus cosine 2x. Now, as you mentioned before, the angle, it doubles from x to 2x. Well, this time, we're dealing with cosine squared 2x. So the angle has to double from 2x to 4x. And that's what you have to be careful with in this problem. So we're going to replace cosine squared 2x with 1/2 1 plus cosine 4x. So everything else is going to stay the same, just cosine squared is going to change. So it's going to be plus 1/2, and then 1 plus cosine 4x. Now let's distribute the 1/2, and let's combine like terms. So it's 1/2 times 1, that's just going to be 1/2, and then 1/2 times cosine, so 1/2 cosine 4x. Now before we integrate, let's combine 1 and 1/2. So you need to get common denominators. 1 is the same as 2 over 2. So 2 over 2 plus 1 over 2 is 3 over 2. And so this is going to be 1/4 integral 3 over 2 minus 2 cosine 2x plus 1/2 cosine 4x. Now the integral of 3 over 2, that's a constant. We just got to put an x in front of it. So it's going to be 3x divided by 2, or 3 over 2 times x. The integral of cosine is sine. So the integral of cosine 2x is going to be sine 2x divided by the derivative of 2x, which is 2. And then the integral of cosine 4x is going to be sine 4x divided by the derivative of 4x, which is 4. That technique only works if the number you're dividing is a constant, which means this has to be a linear factor. It can't be quadratic or cubic. And then finally, plus c. Two divided by 2 is 1, and then we can multiply 2 and 4 to get 8. So this is equal to 1/4 times 3 over 2x minus sine 2x, and then 1/4 plus 1/2 is 1 over 8 times sine 4x. Now you can leave your answer like this, or if you want to, you can distribute the 1/4 to every term. If you do, you should get 3 over 8 times x minus sine 2x. Actually, wait, no, that's going to be 1/4 sine 2x. That would be a grave mistake to make. And then 1 over 4 times 1 over 8. 4 times 8 is 32, so that's 1 over 32 sine 4x plus c. And so this is the final answer for the problem, if you want to distribute the 1/4 term. Or you could leave your answer like this. It's up to you.